How is everyone doing? Good. So my name is Aditya Kaul. I'm a research director at Tractica. We are a sort of small market research consulting firm focused on the applications for AI and robotics. And we look at, we've got a database of about 300 use cases that we've built over the last 3 years or so. So yeah, this topic is very close to my heart. Essentially, what we're going to talk about is how can you redefine your industry with the application of deep learning. And I have 3 very esteemed panelists with me here to talk about it. We have David Nydam, CEO of Business Intelligence Advisors, Sumedh Mehta at the far right, CIO of Putnam Investments, and Tom Wilde, you've, I guess, seen across the 2 days and heard from. So I'll before we sort of go into I'll ask the panelists to do a short brief introduction of themselves, but I wanted to set this up, what we want to achieve, and we've got a very sort of short span of time, about 30 minutes. It's a big topic. There's a lot we can talk about. But what I wanted to do was, I mean, deep learning obviously is the flavor of the day. There's so much going on across the last 2 days. We've heard about everything from object recognition, image recognition, through sort of natural language processing, and all sorts of deep learning techniques being applied to improve the state of the art. So I think all of us kind of understand deep learning from a technology perspective, but I think what we'll try and do on the panel is, what does it mean for business? What does it mean for companies? And how do you apply these techniques to solve some of your business problems? So, and also kind of look at, I mean, deep learning, you can apply it to do sort of very sort of low-hanging fruit stuff, right? Like do cost optimization or do sort of very sort of minimal efficiency gains within your company. But what does it mean from a sort of transforming business models, trying to look at new markets that you're trying to identify, go into completely new areas with deep. So are there examples where we can actually see some of that? So we'll go into some of this. So with that, we'll sort of go into the introductions. Maybe each of you can just briefly talk about yourself and what you do.
Sure. Hi, everyone. I'm Sumedh Mehta. I'm the CIO at Putnam Investments. We're a 75-year-old asset manager, so we manage other people's money, yours. So we have to be very careful how we apply technology and secure the safety of it so that our investment professionals can do the best job possible on your behalf.
Great, and you can skip me because I think they're very familiar with me. So, Dave.
So BIA is about a 15-year-old company. We primarily provide behavioral analysis services to large investment firms and hedge funds. And our particular methodology was based on a spin-out from the Central Intelligence Agency for determining when people are being deceptive or trying to engage in deceptive behaviors. So historically, we've done that on using people, and are now looking at, or beginning to put in place some more technology applications.
Great, Tom, you just say a few words about yourself.
Yeah, sure. As CEO of Indico, these guys are familiar with me from the last 2 days.
Sure.
So yeah, we were focused on applying deep learning to unstructured content problems.
Yeah, just in case people just joined, just making sure. So maybe start off with the bigger picture, sort of the 30,000 feet view, and maybe I'll go to you, Sumedh, for this. As you run a very large sort of investment firm, and you've been around in the IT industry for a long time, in the larger scheme of things, if you look at things like the IT revolution, or look at the mobile revolution, the digital revolution, which is still going through, I mean, how do you put deep learning and generally AI, I mean, let's just not sort of narrow ourselves to deep learning, but how do you put AI in the larger context of these technology revolutions? Is it different? Is it the same? What's common?
Sure. First of all, an observation. I think it's fair to say we ourselves are deep learning people. That's what we tend to do. That's how it works. And this is how well the brain works. Between very smart people in a very smart audience, we can't figure out where to sit. Right? We're sat in the wrong places. There it is in front of us. The directions are clear. The deep learning algorithm should have worked, but it failed miserably. But somehow we say it's completely OK, keep going. Right? And we are trying to now model the world and say a new sort of shift is in place. So I do think, having cited that this way, I do think that this is a technology that is highly relevant to us, because what it tries to do is brings the foundation of computation, which up till now has been developed by mathematicians in mathematics departments, came out, tried to find its way. It wasn't really physics, became computer science. AI came out in the 50s or 60s and then didn't really go anywhere. And finally, computational power is strong enough that decision-making can happen with a set of data that human beings didn't spot. So we're looking at all of this and saying, from exact sciences of how technology worked in databases that we have become so conditioned to, we know exactly what to do with it. It's not like our parents, when the computers were introduced, they didn't know how to use it. We know about it. Our kids know about it even more. The real shift that's happening is computers are changing their behavior from being exact sciences to fuzzy logic and get closer to humans. And as that trend becomes a reality, the way we do our jobs is going to completely change. Today, it represents a huge threat to every level, so there's a lot of friction, and that's true in every revolution that's happened. Initially, there's a fair amount of friction, but over time, if you say 30 years from now, where is it going to end up? I think we will greatly align in this room the use of and adoption of AI technology in our day-to-day lives. We are in it for automation, but we're really in it for productivity improvement at a scale that we haven't yet seen. So that's the evolution that I believe is going to happen, and we are going to deal with these sorts of problems that we can't figure out of 4 seats who should occupy which one.
Maybe we need an AI to tell us where to sit. Anything to add, Tom? Or
yeah, no, I think building on that, kind of on the opposite side of it, we're trying to bring solutions into companies like Putnam. The way we like to describe it is, it's more like a bionic arm as opposed to a truckload of robots, being brought in, because the input of the subject matter experts and the definition of what is a valuable business outcome is probably the biggest missing piece in making the technology useful and for companies to generate an ROI from it.
Yeah, I mean, I would just echo that. I think we typically, or we're more looking at it in terms of not so much how do you replace human cognition or the approach, but how do you enhance it? How do you make them better at what they do? How do you increase their productivity and their ability to apply their expertise?
Okay. Let me just say also that feel free to interject, ask questions at any point, because we just have 30 minutes. I don't want to keep all the questions to the end. I want to make this as interactive as possible, so please feel free to ask any questions. At this point, anybody have any questions, any burning questions to begin with? No? Oh, there's one there.
This question is for Sumedh Mehta. You mentioned earlier that right now basically the structures that we use to convey information and to make decisions are written into very hard and coded objective rules, but that we're going to move more towards the fuzzy reasoning that humans can do. So how is that not going to make everything subjective? Because the whole point of rules is that they are objective and not fuzzy, and they're very clearly defined and articulable and able to be put into formalized language that every human who reads it can understand. But the primary feature of deep learning and the more subjective ones is that humans cannot understand it without, maybe if you look at it thoroughly for hours and hours.
Right, so great question. Now, when I said that computers are changing to become closer to humans as opposed to humans changing to take the form of the computer, we got used to the keyboard, we got used to input devices that were complicated. What's happening now and the way it's going to go in the future is so take a lot of text, for example, right? If you're a lawyer and you get a document that comes in, there's a set of processes that you would go through to analyze it and try and figure something out. If you're really good at it and you've been at the same job for a number of years, you're likely to say, this is within the scope of things that we've done in the past, and I'm going to be generally comfortable with it, but we can argue some points. Now imagine that same document that goes through an AI engine that has the benefit of having gone through every single legal document that you've already agreed to, and to give you information. The productivity level that's needed and the amount of work that you need to do and the kind of work you need to do is completely changed. What did the computer do? It created, you call it subjective, but it's obviously based on data and past occurrences. It's going to cluster the text, assuming natural language processing is working right? Assuming a lot of things are working correctly, it's going to create risk scenarios for you based on what the intent of the words are. It's going to suggest wordings that you have already accepted in the past and may be different now, and it's going to propose to you something that you should take care of. Up till now, where we are with something like that is, I would say, the computer is allowed to highlight, categorize, but not take action in creating the final output. We let the human still do it. Because the way it works is we will not accept an answer from a system that is threatening my role. So I would allow it to do so much and draw lines on what it can and cannot do. And arguably, the technology isn't all there where it could work 100% of the time. So we rely on human beings, who, by the way, make a lot of mistakes themselves, right? So what will the computer do? It will characterize it. It will look like it's subjective because it's learned from the patterns that have been enforced by this organization before. So we are using it to understand legal contracts by breaking them up into 36 different categories to try and understand each of the nuances. All of that is happening automatically, and we are seeing productivity improve. That's what I meant about it's fundamentally shifting and changing. We're not yet at a point where the computers will propose language. It's still left for the lawyers.
I understand. Thank you.
Great. So let's just turn the discussion to what this means for businesses, right? So we were talking about all the different use cases. We've seen a number of use cases. A lot of times when I talk to companies, both big and small, I mean, most of them are looking at low-hanging fruit. And there's obviously a risk aspect to it. You're not really sure about what the technology is. You're trying to apply it to your own business, models. So so maybe David, in your own experience, we were talking about this earlier. How do you see this actually completely changing how companies operate? I mean, in your own instance, I believe that's been the case. Right?
Yeah. So if you look at sort of our history, we've got a very detailed behavioral analysis methodology. We've got 100,000 plus tagged data set. All of the analysis that we've done historically on that is done by people because it's identifying deceptive behaviors and identifying human behaviors is a fuzzy, tricky thing to do. Until recently, when we've looked at the technology side, it's not really been able to replicate that or give us reasonable results. But now we're beginning to see real traction in the ability to use the training data set to enable that. And there's the obvious pieces of looking at that to enable increased efficiencies within our core market, but that's really less of our focus at the moment, which is to now use that to open up entirely new markets. So, historically we've been constrained by which markets can justify the economics of an entirely human-focused person, which markets can justify the time latency of having a person look at things, and what markets can also have robust enough data sets that allow you to extract a lot of information from a small amount of data, as opposed to saying, I have a large data set that I need to pick the needles out of the haystack, because that becomes very inefficient. So what we've now done is to say, well, we have our methodology, we have our data set, now let's use that to go after markets entirely outside of the traditional investor community that we've served. So to look at within near-term or nearly adjacent industries like insurance, that sort of thing, but now begun to look at, for example, the people side of cybersecurity, or hiring, and the ability to validate whether the person you're interviewing is actually upfront about what they've accomplished or not accomplished, those sorts of markets.
So just maybe furthering that a little bit, maybe Tom, I mean, you've got a company who's got a platform and you're applying all these wonderful technologies, techniques to solve problems, right? So how do you sort of go about approaching specific problems? What are some of the best practices? Maybe talk about that a little bit.
Yep.
What are some of the typical mistakes that companies make when they're trying to apply these techniques to solve their own problem.
Yeah, maybe not mistakes, but assumptions. And
Yeah.
Sumedh touched on it a little bit, but this is one of the most fascinating things that we encounter, which is part of our platform allows companies to create labeled training data because that's critical to using deep learning. And we allow multiple labelers to work on the same task. And the real shocker for most of our customers is to see the agreement rate when multiple labelers are working on the same task. And I've seen as low as 20% agreement. And that always shocks them, that they believe they have a well-codified process or routine and understanding within the company of what something means to that company. And when they basically ask several people to define the same problem, they have very different interpretations of it. So you're already behind the 8 ball because if you can't define the process or the outcome you're trying to achieve, the technology is completely irrelevant, right? Of course, you're going to build a bad model with that kind of level of, or low level of agreement. So I think that's an interesting place to start, which is, the business problem has to be well enough defined to even attempt to apply technology to it. In this case, deep learning.
Sumedh, you had something that?
Yes, I just think it's fascinating because we're going to go through a learning process with this technology right beside us. And we're going to make observation that will say, every time human beings tend to carry umbrellas, it rains. Because it's just an observation, right? You look at it, you correlate different types of data together, and you'll draw just weird conclusions. For a computer, it makes perfect sense. For a human being, I thought it would be funny if I said that. But it's kind of funny, right? That you're carrying umbrellas and it rains. It's like a good predictor, you would think. That's how we will see the data, because the business world is actually imperfect. As well as we think we know the process really well, it turns out we actually have lots of course corrections built in. The processes are not well defined. This is what we call domain knowledge, for example. We know how this is supposed to work. We can't write it down. This is why it's been so hard to deliver requirements to technologists to build systems. Because you think when you put it down on paper, you've made 100 different assumptions. And that's how computers work. That's how we should work. But we don't. We are a much evolved species. We correct things. We talk to each other. We communicate. We present information at different times, and we have checks and balances. Those things don't exist yet. That whole ecosystem doesn't exist yet. As soon as we introduce and accept AI-based solutions into our working models, people will start to reframe how they think. The checking and balancing and the domain components are going to get codified in data and logic in computers, so that more people can do jobs that are tricky today and require lots and lots of learning. This is what we're calling augmented. Anytime you can work with a computer to augment your job, you'll produce better results. At least that's the idea. So we will learn different things, and the machines that we use will become it's as close as we are to our iPhones today and our cell phones, we will become that close to our personalized working computers.
Great, so I'll open it up to the floor. Anybody have questions for the panel? Okay, maybe I'll sort of touch upon one aspect that I've seen with deep learning as opposed to, say, classical machine learning or statistical techniques that have been before, where deep learning essentially is sort of more of a perception engine rather than more like a prediction engine. And there's a wonderful book by Ajay Agarwal from the University of Toronto called Prediction Engines, actually. And he argues that the cost of prediction is coming down. Deep learning is playing a very, very large role in doing that. So, and it sort of, he also classifies perception as a prediction problem, which I think there's an argument to that. But I believe that you have to kind of look at it, as a perception problem rather than as a prediction problem. So the question I have essentially is, for companies that are trying to apply AI deep learning, right? So you typically think of AI in terms of data, so raw data, so it's, that you collect from your customers, your supply chain, and then to try to optimize it. But then you also look at images, and, a lot of talk about speech and text. And so those are all sort of language and vision are sort of perception-based problems for me. So how do companies sort of rethink, and maybe Tom, you do a lot of work with NLP, right? So how do you sort of rethink fundamentally how companies can actually become more like a cognitive organization, right? You know, sorry to use that word, but rather than just being sort of a analytical machine, you know, if you understand what I'm saying.
Yeah, and I think for me the most profound, at least in the world of NLP, the most profound aspect of it is we're going from the last 3 decades where we all had to some degree learn how to speak machine. So think about a Boolean query, right? We don't talk to each other with Boolean queries. The machine understands a Boolean query, and we try to codify a request in the form of a Boolean query. What deep learning does is turn that on its head. We just say to the machine, look, these are examples of things that I think are good or bad. Now figure it out and reverse engineer it. So you know, we're moving from, and my background is 25 years in the enterprise search business. So a world of keywords to a world of concepts. And that's really, really profound and powerful, where if you talk to anybody who's tried to do NLP for the last 25 years, they have expert systems and rule-based systems and search-based systems. It's sort of the IBM Watson approach, which is super heavy lifting to make it work well. And so we're at this really interesting inflection point where that goes away and we move towards concepts and context.
Mm-hmm. So we have
about... I'll add that what's interesting in what Tom said was, if you take the business world, our job is to make decisions on, let's say, picking the best stocks on behalf of shareholders and getting it right more often than not. And it turns out it's a very difficult problem, and it requires transparency. So the first thing you say is, can you bring in a computer and can you use AI to figure out everything I've done in the past and pick stocks for me? And it turns out it can't really do that. It's a very difficult problem to get alpha, as we call it, out of a set of processes. But when you talk to an analyst, they will explain in great detail what their process is. And yet it's complicated. And then once you make a decision, it's not good enough, because the PM will always provoke more thought and get deeper into it and ask for, why did you make this decision and why did you do it now, right? So it's not good enough to throw a bunch of data at it and have the deep learning algorithm draw some conclusions because it figured out some correlation, and now you ask the question, why did you why did you pick what you picked? And well, the answer is in the algorithm and the millions of variables, and which one impacted it. Well, you can't answer it. Well, you can't use it in this configuration in an investment world.
Yeah.